Alrighty, so you can see from your notes packet that chemistry is definitely a quantitative science. It's a quantitative world. Chemistry is a quantitative science. Chemists are oftentimes answering questions, for example, as it says there, how many grams of hydrogen and nitrogen must be combined to make 200 grams of fertilizer? And, for the sake of this subject, we must be able to analyze substances, measure the amount of matter contained in them, convert between measurements, and calculate information based on composition and reactions. So that's the gist. We're going to start a little bit here with quantitative stuff, and we'll get all the way into the big word stoichiometry later in the year. But first off, how do we measure matter? Well, one of the ways that we can do this is by counting. So you can count money, sheep, um, any object that's visible and big enough to count, you can count it. So that is one way of measuring matter. Another way is by weighing, and this is very common at the grocery store, for example, or where you buy foods by weight. Also by volume, and so we can usually equate volumes with liquids, but also gases. Like we know that you can get tanks of helium and stuff like that. So liquids and gases and solids, we can measure the volume of solids as well, but all of those are the ways that we can measure matter. What we're going to look at now is the heart and soul of the math in chemistry, and that is converting between measurements, converting from one unit to another. That's what a lot of the math in chemistry involves. One of the ways that we can do this, a tool that we can use, is called dimensional analysis, and I'm going to show you that. It is a problem-solving tool that could be very useful to you now and in the future. Essentially, what dimensional analysis uses are what we call conversion factors. A conversion factor is a ratio of equal measurements. So here we see for the fact that 1 meter equals 100 centimeters. Let me grab my highlighter. 1 meter equals 100 centimeters. We can set up these two conversion factors. They look like fractions. The top and the bottom are equal. 1 meter is 100 centimeters. The numbers aren't equal, and that's why we use them, because we're going to use them to convert. However, the top and bottom are equivalent measurements. So let's see how we can use these to convert. So first up, let's see if we can convert 2.54 meters to centimeters. How are we going to be able to accomplish that task? Well, we're going to use those conversion factors. So what we need to do is take our starting information, 2.54 meters, and we're going to place that over 1. Make it look like one of the conversion factors. Once we have that set up, we need to bring in the conversion factor now that we're going to use to convert. The key here is that whatever unit is here must be down here, the bottom of the conversion factor, because that is how we can mathematically cancel that unit out through cross multiplication. So once we have that crossed out, we can then switch to the unit that we prefer, in this case centimeters. So now that we have the conversion set up, we can do the math. So what we need to do is multiply across the top. 2.54 times 100 is 254. On the bottom is 1 times 1, which is 1. So 254 divided by 1 is 254 centimeters. Label those answers. Again, I know we're using the metric system and you probably have a quicker, faster, better way that you can solve this problem. I get that. But dimensional analysis is a tool that could be potentially useful to us for some more heavy chemistry math. So I would like you to at least be trying these and practicing them that way. Our second example will use the same fact, that 100 centimeters is 1 meter, but this time we're going to convert from centimeters to meters. We start the problem the same way. We put 258 centimeters over 1, and then we will use our conversion factor that will change from centimeters to meters. Again, whatever unit is here, centimeters, must be down here diagonal so that we can cancel it out. So you'll notice this time the conversion factor is upside down. We had 100 over 1 up here, now it's 1 over 100. It's just based on the need of the problem. So now we can do the math again. Multiply across the top. 758 times 1 is 758. 1 times 100 is 100 on the bottom, and then you divide. 758 divided by 100, 7.58 labeled meters. So sometimes we need to make some conversions that are more than one step. For example, here, I would like to know how many milliliters are in 1.5 gallons. This is going to be called a two-step conversion. Now, we can get very complex in chemistry and go multiple steps. About the most we'll get into is 3 and 4 steps. But here we have an example of two steps. So I start the problem the same way. I've got 1.5 gallons, and I put that over 1. So immediately what I need to do is make sure that gallons is on the bottom of the next conversion factor. And that is what we have to do in order to ensure that we will cancel that unit out. The information that was given to me is that 1 gallon is 3.875 liters. So that is the information that goes on top. Liters is not the answer I'm looking for. I'm looking for milliliters. So I must continue on and keep converting. Again, I must pay attention and make sure that the unit here, liters, is on the bottom here, liters. That way, I know that I will cancel that out, and I will get to what I'm looking for, milliliters. And so now, sorry, there's the bell. Now again, I can do my math. Multiply across the top, 1.5 times 3.875 times 1,000 is 5,812.5. On the bottom again we have ones. 1 times 1 times 1. So when we divide, that is my answer. 5,812.5 labeled milliliters. So again, the practicing of the conversions, yes, it's the metric system and some other systems of measurements that we're using, but please try and use some of the dimensional analysis. I will now show you the answers to the practice problems. So if you haven't done them yet, please try them first before you look at the answers. These are the one-step conversions. Notice how every problem you start with your given information over 1. You don't have any units in the bottom. And then you must have the units diagonal from each other. Whichever one you start with must be at the bottom of that conversion factor. And on top is the unit you're looking for. Pause the video if you need more time on these answers. The two-step conversions, again, every beginning is over 1, and we have the diagonal crossing out of the units. People sometimes do these in literally 2 steps, where you do the first conversion, get an answer, and then do the second conversion. That's okay. The goal is to get the right answer. When we get into some more complex problems, it might be harder to stop as many times, but again, it can be done, and that is up to you. That's your choice. Pause the video if you need more time here. The word problems with the conversions, I just want to show you that you can solve these problems more than one way. In this example, number 1, I took the 495 grams of bismuth, changed it to kilograms, and then I added that to the kilograms of lead, and then I converted that into the milligrams. You could have changed this and this, the grams and the kilograms, into milligrams and then added them together. You could have even changed lead into grams, add that together, and then change to milligrams. So there is more than one way to do that problem. The goal, get 3,021,000 milligrams as your answer. Same with the second problem. The second problem here, I chose to subtract first. 2 liters minus the 1.47 liters of water. That's how much water it will take to fill. I converted that to milliliters. You could have converted 2 liters and 1.47 liters into milliliters first and then subtracted. Again, the goal is to get the right answer. The last problem, I think, is pretty much only one way to do it. You convert the centimeters to millimeters, and then you divide by the 50 to figure out how many segments. So that is conversion and dimensional analysis, a nice introduction. We will return later for mole information.